Hello and welcome to another video on swans. Just kidding. We're on Programming Principles and Practice using C++, 3rd edition. We left off finishing the terms, and now we'll be moving into the exercises of Chapter 2 on objects, types, and values. We'll see how far we get in this recording. Let me pause the autofocus on the camera because it likes to do things like that. You know, that book is just moving so fast, it needs to be... Seems about right. Okay. My bones! Okay. So, we have... Exercise 1. If you haven't done so already, do the try this exercises from the chapter. Well, we have done all the try this exercises in one of the previous videos, which was the chapter 2 objects, types, and values video. So that's completed. Number 2. Write a program in C++ that converts from miles to kilometers. Your program should have a reasonable prompt for the user to enter a number of miles. Hint, a mile is 1.609 kilometers. Easy peasy. Let's get that done. Open up Visual Studio. Create a new project. Empty project, C++. New. Move the coffee out of the way. Grab the keyboard. Let's type this in. PPP3. Chapter 2. Exercise. Well, I think it's this PPP3 exercise. 2.2. Go to source files. We want to add a new item. main.cpp. Right click on our project. Go down to properties. Go to C/C++, go to General, scan sources for module dependencies, do yes, hello truck. Go to language, C++ language standard, choose STD, C++ latest, and build ISO C++23 standard library to yes. Apply these changes and build so it compiles the standard module. Okay, and that worked. So then we give a description to this program. Through this program. Miles to kilometers. Import SD. Main. We'll have a double for input. Expected miles. We have a double miles to kilometers. Ratio. I'm going to get that definition from the book, which is 1.69 kilometers. 609. And then we're going to use going to use cout, output operator, to prompt the user. Please provide a value with miles. Miles to be converted to kilometers. Then we'll use cin with the get from operator into input. Let's call it miles input. And then we want to print out the miles input equals hello train. Miles input equals, we want miles input multiplied by the miles kilometer ratio Alright, let's a new line on that. Terminate with a semicolon. Turn 0. Get rid of some of this empty lines. Let's give it a go. Please provide a value of miles to be converted to kilometers. So let's do 1 mile. There we go. 1 miles is equal to 1.609 kilometers. Oop, excuse me. Alright, I believe that answers that exercise. Let's save all. I'll just leave it open. Alright, let's bring up the book. Okay. Number 3. Write a program that doesn't do anything, but declares a number of variables with legal and illegal names, such as int double equals 0, so that you can see how the compiler reacts. Okay. Let's go overboard with this. File, new, project, empty project, PPP3, exercise 2.3. Go to source files, add a new item, main.cpp, right click on our project properties, go to C, C++, go to, general, okay. The scan sources for module dependencies to yes, go to language, C++ language standard to latest, build ISO C++ 23 standard library to yes, apply these changes, build solution. That appears that worked. This program produces no output, but does show name legality. Oh no. There we go. I keep doing that. Okay, it shows name, it does show naming convention legality. Naming legality, okay. So let's import std. Not sure if we actually need that for this one, but we could do it anyways. So let's do the example it gives us. Double x equals 0. Int string. Okay, naming conventions. Int il 1 0 o max b. Oh well. Okay, this produces an invalid combination of type specifiers. E0084 error. Then we'll comment it out. This is legal, but to be avoided due to similarity of characters. This is legal, but none does not need monomic. Spell checking. Hey, we spelled it right in the first time. Derived from ancient Greek. Mnemonikos, which means of memory. Doesn't help with understanding its purpose. Let's just give a value. Boat equals 10. Produces and E0020 error unidentified variable, the identifier. Comment it out. Write a program that doesn't do anything, but declares a number of variables with legal and illegal names. Okay. All right, let's do a couple more examples of it, and we'll close this exercise out. Because we could be here forever. There's a select number of legal names, and there's an infinite set of illegal names. All right, int star path. Don't tell me that works. Alright. That confuses me. Does that compile? It does? That's a legal name? I thought there were no special characters. What is star path? Is it a thing? No, it's not a legal identifier. That is odd. Huh. I guess this is considered a letter. Let's try to use it. Exit code 20, yeah, it worked. Oh, that certainly surprised me. Well, I guess I got that review question wrong. I would have expected the $sign to be a special character and it would not work. Interesting. Surprisingly works. Money sign must be considered a letter. Hold on. So let's do this. Char C equals turn int C 36. Okay, let's go to the ASCII table. Let's try to find a website that doesn't require ads to look at the ASCII table. Alrighty. Printable characters. Okay, it's called the dollar. Called dollar. Guess it works. Okay. Alright. And that little test works as well. Alright, let's do a number in front. Okay. Okay, I'll leave it as here. Write a program that prompts the user to enter two integer values. Store these values in int variables named val1 and val2. Write your program to determine the smaller, larger sum, difference product, and ratio of these values and report them to the user. Okay. Math. Now we're getting somewhere. File, new project, empty project, C++, beep, 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 3, exercise 2.4. Source files, add, main.cpp, project properties, general, scan sources for module dependencies, yes. Change the language standard to latest, and the build the SDA library to yes. Hit those OK. This program gets two integer inputs from a user and outputs the smaller larger some difference product and ratio. These values. Then we want to import these, so we have that int val1, int val2, cout, please provide two ints separated by a space. Then we go cin with the get from operator, get val1, and then get val2. Then I want to you inputted val1. Val2. Let's check to make sure this works. So far, test early, test often. So 10 and 12, you inputted 10 and 12. All right, that works. Okay, cout. Oh, wait, we gotta check the val1. Excuse me. Val1 is less than val2. Print out val1 is the smaller value, or equal to I'm going to add some more functionality. Let me say that's the smaller value, and else if val greater than val1 equal to val2. Hold on. How can I do this? Alright, so let's do this. So we're going to check for equality, and then if they're equal, we're going to print out val1 is equal to val2, and then if they're not equal, we're going to determine which one is the bigger one. Well, the smaller. Good old copy paste from up above. And that's not true. Go down here and swap these around. All right, let's test this. 1 and 2. You inputted 1 and 2. 1 is smaller than 2. Let's provide 2 and 2. You inputted 2 and 2. 2 and 2 is equal to 2. And then let's give 2 and 1. 1 is smaller than 2. Okay. Okay, that covers smaller value. Now we want to do larger value, in which case we're gonna sort of copy paste what's above, because that's not, this isn't gonna change. We'll swap this around and swap the word around. Oop. And then let's give that a go. So 1 and 2. 1 is smaller than 2 and 2 is greater than 1. Okay, that's good. But not greater, we want larger. Now let's test the opposite. 1 and 2, whoops. 1 and 2. 1 is smaller than 2, 2 is larger than 1, that's correct. And then let's do 2 and 1. 1 is smaller than 2 and 2 is larger than 1. Okay, it's working. Wait. We gotta check one more thing. 2 and 2. Alright, we got 2 equals. Okay. So we did the smaller value, we did the larger value. Alright, what's next? Sum. This is easy. This will be just one line. See out. Val 1 plus val 2 equals val 1 plus val 2, and then the new line character. Let's check this. 1 and 1. 1 and 1 equals 2. Let's try negative numbers. 1 and negative 2, negative 3. Alright, that works too. Ooh, let's try it on the comparative operator as well. Negative 2 and 1. Alright, that's working. In that direction. How about negative 2 and 1? And then let's do negative 1 and 2. Yep, okay, all that is working. Alright, so let's move on. Difference. Let me copy a lot of this code up here. Effectively, all we're going to change is the plus to minus. And let's do 2 and 2. 2 minus 2 is 4. No, 2 minus 2 is 0. 2 plus 2 is 4. Okay, that's working. And then we want to do product. We're gonna copy the line above, just as before. We're gonna use the X. And then we're gonna use the asterisk. Let's do 2 and 3. 2 times 3 equals 6. Let's do negative number, 2 and minus 3. Negative 6. Alright, that's working as well. All right, now we're doing product. We want to move to ratio. How will that look like? Just that? Is that the ratio? 2. The ratio 2 to 2 is 1. It's a 1-to-1 ratio. No. Maybe it's this. Two and 2. There's 1-to-1. Let's try 3 and 6. Uh-oh. 0 and 2. That should be 1/2. So why did we get that? That would be 6 divided by 2 divided by 6. Two, 6. Alright, so it becomes 3 because 6 divided by 2 is 3, but 2 becomes 0 because 2 divided by 6 equals some fraction, but we're using integers. So it becomes 0. Now how can we do this? Can I? I think the opposite will break. So if we do 6 and 2. Yes, the opposite will break as well. How can we get this to work? I think if we multiply and then divide by the largest value, it might work. Depends. Alright, so let's take it here. Larger value. This will work if it's equal to. We'll leave these blank till we figure out how to do it. So if val 1 is larger than val 2, let's multiple of val 1 then multiple val 1. And then if the opposite is true, multiple val 2. Let's give that a go. So 2 and 3, 2/4. It's not. Oh, that's just wrong. Two and 6. 2 and 18. Is that right? That is not right. Maybe it's the opposite. 2 and 1, 2, 1. 2 and 6. Nope. Okay. Very flawed thinking. Okay, let's try to think of this. Paper time. All right, so say we have, oh my God, take the keyboard away. Sorry. Okay, so we have x over y. We want to show this ratio in smallest form. Smallest form. In which case we can say the ratio x over y has some common denominator, d. We want to get d to 1. Okay. How can we find d? I guess we could iterate from 1 till d equals some value starting at 1 till the modulus operator does not equal one. No. All right, so it's like, how do we find the common denominator 3 by 6? Well, if we check by 1, we divide each by 1, we get 3. 6. That works. If we divide both by 3, If we modulo that, we would get 0. If we modulo that, we would also get 0. So no remainder, so it evenly divides. But if we were iterating, we would have tried to the modulo 6, that would equal 1 and 3, which is not valid. So maybe we need to work backwards. Okay. Let's work backwards. So we have 3 divided by 6. We will find the largest, which is 6 in this case. And then we will 3, 6, modulo by 6, modulo by 6. And this will be 3, this will be 0. But we need both to be 0. And then, well, that failed. So then we'll do 3, 6, a modulo 5. And this will also fail. That will equal 3 and 1, I think. But eventually, we will hit 3 over 6 modulo 3 modulo 3, and we will get 0. Over 0. And this be correct. Okay, so I think we found an algorithm to find the smallest common denominator. Well, the greatest common denominator, which will be 3 in this case. Alright. Alright, that's some pseudocode, or at least it's in my head, of how to write this find greatest denominator. I will avoid writing it in, let's write it in a function. Keyboard, welcome back. Okay, so we want to int I equals, no, we actually do want that larger value. So it's an int I, largest val. If they're equal, largest val equals val1. If val1 is greater than val2, val1 is equal to val1. Largest val is equal to val1, and else largest val equals val2. Then the for statement, I don't think we've been introduced to the for statement yet, but I want to use it. And we use the while statement because we have been. Well, largest val is greater than 1. If val 1 modulo largest val is equal to 0 and val 2 modulo largest val is equal to 0. We want to break out of the loop because we have now found it. And else, the largest val, we want to decrement it by 1. And then we want to print out val 1 divided by this largest, not largest val, whoops. Oh, it is the largest val. Yeah, we want another integer. Largest common denominator. Largest val. Excuse me. Val 1 divided by the largest common denominator. And val 2 divided by this largest denominator. Alright, let's give this a go. See how crazy I am. Hey, look at that. That seems to work. 2 and 4. That seems to work. 3 and 9. That seems to work. Now let's try the opposites. 9 and 3. That works. 4 and 2. That works. Let's try the same number. 4 and 4. Woo! Ain't that cool? We just did some math. We just wrote an algorithm to find the greatest common denominator. Wow, that's cool. All right. Okay. That works. It was pretty funny. Completely valid ratio is we just printed this. So we just said ratio equals, and we could just do val 1 with the division symbol. Val 2. And it would be so let's do 2 and 4. Yeah, ratio of 2 to 4 is 2 to 4. That's totally valid, but it's not in lowest form, which is the convention. We went above and beyond and put it the lowest form. So that's the easy answer. This is the hard answer. One line versus... I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 statements. Minus 1. 14 statements. Oh. Oh, dude. Okay. Believe that answers and exceeds what we were expected to do for exercise 4. Let's bring it up. Let's go to number 5. Modify the program above to ask the user to enter floating point values and store them in double variables. Compare the outputs of the two programs for some inputs of your choice. Are the results the same? Should they be? What's the difference? Well, we can't do it the same because the modulus operator doesn't work on doubles. Okay. Let's cheat a little and copy this before we even create the project, and because we're going to reuse a lot of the code. So pp. Let me redo what I just did. So I right-clicked on the project, scrolled down to the Open Folder in File Explorer, found our main CPP, and I just hit copy on it. Okay, and now we're going to open up a new project. New empty C++ project. We go ppp3 underscore exercises 2.5 exercise 2.5. And then we want to do a similar thing. We want to open the file folder in File Explorer, and then we're going to paste in that main.cpp. Now you may have noticed, oh, where is it? It's not here. Well, we need to add it. We need to add an existing item. Select main CPP and add. Alright, now that we have it added, it popped up, but hey, things are broken. That's because we haven't changed the project settings. C, C++, scan sources and the module dependencies to, yes. Language standard, the latest, and build standard library, yes. Okay, we do want to build. Understood. And we have no errors, no warnings. If we run it, it's our old program from before. Okay, so let's change these. Floating point values. Let's try to be lazy. Just do the bare minimum. Let's see what that does. But it failed. Why? Probably because of the modular operator. Yep. Integral or enum scope. So we're going to cheat here and use the ratio. And that's it. 2.0 and 4.0. 2 and 4. Let's give it 2.2 and 2.4. You imported 2.2 and 2.4. 2.2 is smaller than 2.4, correct. 2.4 is larger than 2.2, that's correct. 2.2 plus 2.4 equals 4.6, which is correct. 2.2 minus 2.4 equals negative 0.2, that's correct. 2.2 times 2.4 equals, oh gosh, I have to do math. Well, 4 times 22 equals 88. And then 2 times 22 equals 44. Yep. So 44 and 88, that 8 does get 8 plus 0 equals 8. 8 plus 4 is 12, goes up here. 4 plus 1 equals 5. Okay, so that works. And the ratio is just, that is technically correct. Technically correct. The best kind of correct. Well, that's done.